Coming up, Jonathan visits a cave filled with shrimp. And you won't believe what they eat. Welcome to Jonathan Bird's Blue World.
When we explore caves, we see a lot of pretty formations, but we rarely see very much life. Underwater caves are extreme environments for the survival of life. Without the sun to power the production of plants, there's almost nothing at the base of the food web to support life. But if you look hard enough in some caves, eventually you might find a blind cavefish, a crayfish, or maybe even a rare salamander. Dr. Fernando Calderon Gutierrez is a biologist at Texas A&M University who studies underwater cave fauna.
So when we are talking about underwater cave fauna, there is a lot of species that are endemic to a single location. So that has a really big importance, especially when we are talking about conservation.
Fernando conducts a lot of his research in the Yucatan and Cozumel Island, looking for unique species found nowhere else. Today, Todd and I are going to be documenting and maybe even assisting Fernando with his ongoing research at a very special cave.
We'll get it in. It is going to be like 3 teeth in here.
We meet early in the morning to discuss the plan for the day. And by the sound of it, this will be a really long dive to complete everything Fernando has planned.
So, and this is the part that we have worked before.
Our destination for the day, Cenote Crustacea, situated only about 500 meters from the ocean. It contains one of the most unique cave systems in the world. It even has a super-duper access road.
Do you think our rental car can handle this, Todd?
So far.
For an extra element of fun, the water is about 10 feet below, so we get to go cave diving and cliff diving.
There is a coconut around here.
Our friend and expert cave guide, Christine Lowe, is here assisting Fernando. But someone really needs to sharpen the machete.
I cannot even cut that time.
While Christine battles the weeds, Todd and I start getting gear in place. Fernando rigs a rope to drop tanks down to the water.
I'm a little nervous because I can't see the bottom. So I don't know if it's really safe to jump, but they assure me that it is. We talk about trust me dives. This is a trust me dive for sure. All right, we good? All right, Geronimo. Ooh, there's an overhang here.
That's the cave entrance.
Once I'm in the water, Todd sends the tanks down.
Right tank. Okay.
Next, it's Todd's turn. And Noah sends his tanks down.
I'm a little concerned about this cenote because I can't see squat. It's got like 3 feet of viz. So I'm hoping it gets a little clearer when we get underground.
Meanwhile, Christine walked down to the exit point, which doesn't involve jumping in. Well, what fun is that? We still send her tanks down the rope, though. Last but not least, our fearless leader joins us in the water.
So we're about to enter into one of the caves that is only for research. It doesn't have any other access unless you want to do working with exploration or working doing science in here. And this is very unique because it's one of the places that Remipedes, that are these little kind of like worms but are actually crustaceans, are living here with very high populations. Any other place that would be very rare to see, if ever.
Here comes your other tank.
Thank you.
Very important to watch the dome.
You ready?
Yep.
Tanks are one thing, but lowering the cameras makes me nervous.
Okay. Would you look at that? Amazing.
With all of us and our gear finally in the water, it's time to start the dive. Just below the surface, things are not looking very good with the visibility situation. We definitely need to stay close to each other and keep a hand on that line. There are a ton of different passages going off in different directions. It looks like a spider web down here. Fortunately, Fernando knows which line we want to follow to get to the right passage. After carefully marking our way out with a cookie, Fernando leads the way in, hauling a big sack of jars and syringes for taking samples. I can smell the rotten egg aura of hydrogen sulfide seeping around my mask. It comes from all the decomposing organic material falling into the cenote from the surrounding jungle. After only a few hundred feet, the water clarity has improved a bit. Now it's just milky, and we can swim a little further apart. Along the rocks, a dusting of fine organic sediment, the byproduct of all the decomposition. In places, the sediment is so deep that the line goes through it. We reach a section where Fernando's going to do some work, so he stashes one of his big bags on the line. We keep passing through a halocline, a boundary between saltier water on the bottom and fresher water on the top. Fernando wants to know not just the salinity, but what's in the water. So he takes a water sample near the ceiling of the cave with a massive syringe that slurps in water as he pulls the plunger out. Next, we descend down through the halocline into more saline water. Down here, the visibility is quite a bit better. Fernando takes a water sample right above the floor of the cave. Keeping track of all these samples requires copious notes on his waterproof slate, which is kind of like a notebook made out of thick plastic pages. He also gathers a sediment sample. Someone's going to be busy in the lab later. As we move deeper into the cave, the passageway has tilted up shallower, and we're back into some hazy water. The clouds in the water are an important part of what makes this cave special. Containing methane and hydrogen sulfide, the clouds originate with the decomposition of organic material near the entrance. Soon we start encountering some cave fauna. A Tiflatia shrimp. As a cave-adapted species, it contains no pigment or eyes. As we swim deeper into the cave, we start to encounter more shrimp. This one is carrying eggs on its abdomen. To learn if the Tiflatia species in this cave is the same or different than Tiflatia in other caves, Fernando needs to collect a couple specimens. You would think it would be easy to collect an animal that can't see you, but in fact, they can sense water movement with extreme sensitivity. But this is not Fernando's first rodeo. He has a few tricks. A few notes on the depth and conditions to go with the specimen. And then, we're back on our way. We're searching for a data logging instrument that Fernando needs to retrieve, and he isn't exactly sure where it is. While he's hunting for his lost gear, I'm distracted by the ultimate cave animal, a remipede. These little guys are incredibly rare. It might look like a bristle worm to the average diver, or maybe a centipede. But this is no worm. It's a crustacean, more closely related to a crab than a worm. But it does move somewhat like a centipede. Remipedes only live in caves and only in salt water. The first living specimen of remipede was only discovered in 1979. They get their name from the Latin meaning oar-footed, which seems quite appropriate. Swimming with undulations of up to 32 pairs of appendages that do work like oars, these cave predators are the only known crustaceans that produce venom. Like the shrimp, they have no eyesight, but they have a highly developed olfactory system that allows them to find prey in the darkness. To really see what's going on with this fascinating little critter, slowing it down to 50% speed helps. But I'm so fascinated by this animal that I switched the camera over to 120 frames per second so I can slow it down to 25% speed. And now you can really see how the remipede moves. It's not walking, it's swimming, really close to the bottom. The light from my camera creates an illusion to us as visitors to the cave. These animals live in total darkness all the time and hunt using chemoreception and sensitivity to the tiniest water movement. If I turn my lights off, I can't even begin to understand this world. I've stumbled into a half a dozen remipedes since I entered this section of the cave, and that seems strange. There's a reason why they call this Cenote crustacea. While remipedes often hunt near the floor of the cave, sometimes they swim up into the water column. and this affords a better look at their busy appendages. Fernando calls my attention because he found his data logger. This measurement equipment has been in here taking all kinds of measurements, things like salinity, temperature, depth, pH, for a whole year. He needs to take it out, get the data, change the batteries, and then on another dive, bring it back. He's carrying a similar device with him that's automatically taking water measurements as he swims. Every once in a while, he pulls it out and does some specific measurements. When it's time for another water sample, Fernando lets me do it. It's a lot harder pulling that plunger out than you might think. As we move on, Fernando points out that we're now surrounded by dozens of little white particles in the water. I look closer and realize those are all shrimp. Fernando decides it's time for another specimen. He makes that look easy. I'm anxious to film this section of cave in a way that really shows just how many shrimp there are. You have to understand, in a normal cave, we might see 1 or 2 shrimp on the whole dive. I'm looking at hundreds, even within the limited visibility. Between the shrimp and the Remipedes, Cenote crustacea really is crawling with crustaceans. On the walls of the cave, I see some fuzzy brown stuff. It almost looks like moss. But obviously there are no plants growing in a place with no light, so it's not a plant. Fernando is studying this stuff. He gets a little video with his GoPro. He has a macro lens attachment that allows him to shoot close-ups. This fuzz is some kind of bacterial mat and something that he needs to sample. It's not a delicate process, but he scrapes some of the fuzz into a sample container. It's simply incredible to be swimming through essentially a cloud of marine life in a cave environment. And this begs the question, what are they all eating? I don't have to wait long to find out. There's another kind of bacterial mat in here. It's orange and covers the rock in places. And when I look closer, I see a bunch of shrimp on this orange stuff. These bacterial mats seem to thrive best right around the halocline, which I disturb as I get closer. The shrimp seem to hang out just below the halocline, right under the bacterial mats, and they look like they take trips up into the halocline to feed on the mats. It reminds me of a hydrothermal vent community. Bacterial colonies are surviving on hydrogen sulfide and methane in the water. The bacteria, in turn, become food for the shrimp. No plants or sunlight involved. The bacteria are what we call chemoautotrophic, as opposed to plants, which are photoautotrophic. Fernando whips out his handy GoPro again because he's caught a glimpse of a rare sight. A remipede has caught itself a shrimp for dinner. The food chain in action. We aren't sure where it's taking its prey. Do they have a secret lair? Another mystery. Finally, after 3 hours in the cave, we turn and start heading for the entrance. We have another data logger to pick up. But the location of this one is well known since it's zip-tied to the line. With a little gentle cutting to be sure we don't damage our way home, Fernando cuts it free. We can tell we're getting close to the entrance when the visibility gets worse from all the tannins in the water, and that hydrogen sulfide smell comes back. From just 25 feet deep, we can barely see daylight. We have a few minutes safety stop before we can surface. Up above, it's a nice sunny day, but you would never know it down below.
Well, I guess we know why they call it Cenote crustacea. Wow. I've never seen so many bugs. It was like fireflies on a summer night.
Just like swimming through shrimp.
Thousands of them.
Everywhere, like rain.
Amazing. Normally in a cave you see like a shrimp.
Yes.
Like one.
Yeah.
This was thousands.
They were everywhere.
Amazing.
It's a pretty unique place. I've never seen anything quite like that.
Back at the condo, some of the samples go straight in the freezer. But Fernando has a little field lab set up to do some initial observations while his specimens are still alive. He has a video microscope so we can see what the shrimp look like. Sometimes it can be very hard to tell one species from another.
So you can see this one is around 1.5.
Fernando looks at small details like the antennae and appendages to distinguish one species from another.
Now it is not moving a lot, but you can say like,
Yeah, he's moving.
so it is still alive.
But ultimately it may come down to DNA analysis.
We use a couple of legs and we extract the DNA from there, and then we do different analysis.
Why does it matter? Because if a cave has a unique species found nowhere else on Earth, it may need special protection to ensure the survival of that species.
Put it at one side or...
Caves are incredible places to look for new forms of life. The extreme environment inside a cave means that organisms have to survive without the power of sunlight or the ability to see. We're just visitors to this dark and mysterious world, a world that doesn't surrender its secrets easily. But inquiring biologists like Fernando Calderon Gutierrez are slowly bringing their secrets out into the light. Hey you guys, check out that video. It's a really good one. Also, this one's pretty good too. Oh, and don't forget to subscribe.